Hello. Today we're going to look at organic polymers. The first polymer we'll make will be polystyrene. It is an addition polymer in that the empirical formula for the polymer is the same as the monomer. In other words, all the building blocks of the polymer are the same exact molecule. When we do a polymerization, we often will initiate it using a radical. In this case, we'll utilize the benzoyl peroxide and a little bit of heat to break this unstable oxygen-oxygen bond in a homolytic fashion. We'll give one electron to each of the oxygens, and that'll produce two benzoyl radicals. The benzoyl radical will then will interact with a styrene molecule to produce the styrene radical. This can then interact with another styrene molecule to build a little bigger, one bigger polystyrene. It'll keep going in such a manner until it reaches a termination step. All right, here we are. So we're going to take liquid styrene, and we're going to take a white solid, which is the benzoyl peroxide, and then we're going to add the styrene to a 150 ml beaker. Okay, we're going to add the benzoyl peroxide to that mixture, to the polystyrene, and then we're going to stir. Now what's going to happen is, as this begins to heat up, you'll see the mixture start to turn yellow, and it'll get very exothermic, so we'll have to take it off of the hot plate for a short while. And after the exothermicity reaction is over, we will put it back on the hot plate and continue stirring until we can pull up lots of thick strands of the polystyrene. Now it's still going to be hot, so it will be melted, but it'll quickly solidify in the watch glass we're going to pour it into. And then we'll come back when it's cool, and the polystyrene should come off the watch glass very nicely. You can see the benzoyl peroxide has dissolved into the styrene. Now we're going to wait a little bit longer till the reaction turns yellow and exothermic and remove it. The heat is used to scissor the OO bond, which is relatively weak in the benzoyl group, to form the benzoyl radical. When that happens, the reaction will initially be very exothermic, but then will begin to moderate as the addition polymerization continues. I think we're beginning to see a little bit of yellow formation, so it'll become quite vigorous, and I will need to remove it from the hot plate, at which point I will pause the video and resume it after the exothermic reaction is mostly over and continue heating it on the hot plate. The reaction is definitely turning yellow. You can see there's a yellow tinge to the reaction mixture. And pretty soon it'll get very exothermic. You can see a little bit of the, maybe you can see in this video, a little bit of the polystyrene superheating coming off, condensing on the sides of the beaker, where it's cooler versus the bottom where it's hot. And I'd like you to be able to see the exothermic reaction before I pause the video. I have safety goggles and gloves and a lab coat on. Normally I'd have the hood running to keep the fumes away, but that would impede you hearing me. So I can smell the styrene a bit, which is not healthy, but I'll be able to turn the fume hood on once I pause the video. I'll let that sit a second. We'll watch it. It's getting quite smelly. I'm going to turn the fume hood on. Hopefully you'll still be able to hear me. You can hear the fume hood activating. Hopefully it's not overpowering my voice. But I need to vent some of that styrene. And so as you can see the reaction taking off. So I'm going to remove it, and I'll pause the video and we'll come back. Alright guys, so it looks like the exothermic reaction has slowed down. I'm going to put it back on the hot plate. Now the reaction vessel, the beaker, is very hot, so I use beaker tongs. Now I will continue to stir this. If it goes as planned, there'll be a smooth, steady polymerization of one styrene radical to another styrene molecule, which will produce one longer chain unit, and it'll continue on. This takes a little while, so again I'll pause the video and I'll come back and show you what it looks like when it's ready to pour into the watch glass. Alright, so it's been about 5 minutes of cooking time, and you can see that it's gotten thicker. Hopefully you can see that. However, it's still not ready, because if I poured this into the watch glass now, there'd be much unreacted liquid styrene, so the polymer would never fully solidify. How I'll tell if this is done is I will pull up the stir rod, and I'll see long threads that come up and solidify rather quickly. You can see that I don't really see that yet. So it's time to pause the video one more time, and when I come back, hopefully we'll be ready to pour it into the watch glass. Alright everybody, it's been about another 5 or 6 minutes of heating. You can hopefully see that this is a really thick liquid now, because it's still hot. It's still a melted polymer, and I pull the strand, you can see big long strands come off. So what I will do is I will carefully pour this into this watch glass at this point. Look at that. The temptation is to do this too soon and resulting in a material that won't solidify in a nice solid disc. Try to get out as much as I can while it's still hot before it cools off. You can see it's already starting to cool and help and solidify a little bit. I think that's probably enough material now. Let me get this rest of this off of here. Okay. Now, look at that. Strands coming off. Huh. Doesn't want to give up, does it? There we go. Alright, I'll put this aside. So next time we come back, I'll let this cool, and we'll take that off the disc, and we'll have a little bit of polystyrene made. Okay guys, it's time to look and see if our polymeric polystyrene has actually been formed. If everything goes well, this should just slide off the watch glass. Let's see if it does. Oh, it does. Look at that. We have now successfully made polystyrene. Awesome. All right.